Have you ever wondered why some video calls are crystal clear, while others suffer from frustrating freezes and choppy audio, even when your internet speed seems fine? That inconsistency, often more impactful than pure speed, is precisely what we are examining. While there isn't one single global, standard, for jitter calculation from latency measurements, the most widely recognized methodologies stem from recommendations by the Internet Engineering Task Force, particularly RFC 3393, which describes packet delay variation, and the International Telecommunication Union, known as ITUT, which provides definitions for network performance parameters. These frameworks guide how network engineers quantify the variability of packet arrival times. The why behind these approaches lies in understanding that latency is the time it takes for a packet to travel from source to destination, while jitter is the undesirable variation in that latency over time. Imagine packets arriving at irregular intervals, some early, some late. This uneven flow creates problems for real-time applications. The calculations aim to quantify this variance, often using statistical methods like standard deviation on a series of latency samples, or by measuring the inter-arrival time differences between consecutive packets. To calculate jitter from latency, you first need to collect a series of one-way latency measurements for packets sent over a period. Each measurement represents the time elapsed from sending a packet to receiving its acknowledgement or the packet itself. Once you have these individual latency values, you can determine jitter by computing the standard deviation of these latency samples or by calculating the differences in arrival times between sequential packets. For example, if packet 1 arrives in 10 milliseconds and packet 2 in 12 milliseconds, the inter-arrival time is 2 milliseconds, and the jitter would be the deviation from the expected inter-arrival time. A key concept here is packet delay variation, or PDV, often used interchangeably with jitter, which is the difference between the maximum and minimum packet delays in a stream. Another important metric is inter-arrival jitter, particularly relevant for voice over IP, which measures the difference in arrival times of consecutive packets. Ensuring accurate time synchronization between the sending and receiving devices is crucial for reliable one-way latency measurements, as even tiny clock differences can introduce significant errors into your jitter calculations. Ultimately, understanding how to calculate jitter from latency samples provides network administrators and developers with a powerful diagnostic tool. By accurately quantifying this variability, you can pinpoint network bottlenecks, optimize routing paths, and ensure a smoother, more reliable experience for delay-sensitive applications, whether that is for financial transactions, cloud gaming, or critical video conferencing.
If you love understanding how the web works, like, subscribe, and stay connected with us.